in order to get the Gazebo and Arviz to work together, you have a lot of steps to take. First, you want to build some directories that are going to house some packages and Zacro files like this, and launch files that you make, which will all be, either XML or YAML. So there's a lot of files that you need to make and create in order to get the robot to actually move. Then you have to make a move it configuration file, which is actually done through the terminal. I don't want to go too deep into it, but you go through the terminal and you will, what is it? The command is in here somewhere. Let's see if we can find it. ROS launch, move it, setup assistant dot launch. So if you were to run that command, then you get a little window that pops up that allows you to configure your package, and you basically can create this package and it'll have a lot of these systems in here. And there's a few important files that we go through editing. For example, joint names, we can name all of our joints. That's an important file to have. Another one that I went into the simple move it controllers and listed my controllers here, but was still running into a few problems. So we actually went into the ROS controllers file and added some more information here. So usually these aren't filled up. You have to put this information yourself, and you can source it from the package you download from beforehand, which is right here. So in order to get all this set up, you go through a step-by-step kind of setup here, and the first step is installing the universal robot, which you can go into UR description and find the URDF files and kind of look at how they have it set up. For example, this is the URDF file for the UR5, and for the one we created where we moved the robot, we looked at that and went into, made our own description and made our own URDF, my UR5 URDF file, and this is our file where we actually edited the values there and changed some of the script around. So you have to make this move it configuration file. We went through some of the config files that you're gonna need, like joint names, ROS controllers, simple move it controller, that kind of stuff. Other things will just exist there that you won't really need for this exact thing. Then you go into launch. In launch, there were a couple things that were important. So like we're gonna be using move group, which we don't really touch, but we are gonna be, it's gonna be used. Move it Arviz is going to be used, but we're just referencing it in other files. There's one called, let me see, trajectory execution is gonna get used, but we don't necessarily mess with it. I think the important ones for this is we make an execution planning launch and a move it controller. So my UR5 planning execution right here. So we edit this file and we, make it an XML and talk about, or we reference the certain things we need to reference in order to get the controller working and the system working in general. And then we also mess with this one, the simple move it controller, which you can probably rename. I kept it the same name because I was worried about how the name would be referenced in other files. But once you format all these files how you see fit, you should be able to run the two systems that you made. And those two systems, those files are actually, if we go back through here and we Control C, we see that when you launch your robot, you can ROS launch my UR5 description, my UR5.launch, or this one, which will launch, this particular one will launch Gazebo with your robot on its pedestal that you end up making inside the code, right? And then ROS launch my UR5 move it config, my UR5 planning execution.launch will launch it in Arviz. And it's important to actually launch it in Gazebo because that's your first node that you want, and then your second node will be Arviz, in which then they can communicate. There's a few settings on Arviz that need to be figured out, which we can make, I guess I can add a little video for that, but that's the general idea of how you implement, move it, and have a robot move using Gazebo. And we'll have a short video that kind of shows the actual robot moving correctly. Thank you. So here I have the robot on Gazebo down here, the robot arm, and then I have the robot arm here on Arviz, and they've just reached their original position to their home pose position. I don't know if I can, let's see, I'm going to set the goal state to be the previous state, and the start state being home pose, and see if we can't plan that out and show it. So we're gonna hit plan. It's very laggy, extremely laggy, and it looks like the plan, it did work there. Now we're gonna watch it do on the real robot. We're gonna execute as the robot moves down into its original position. Then we're gonna go back to home position and show it working again. There's the robot moving in Arviz and in Gazebo. Now it's showing the next position. So from here, our start position is now going to be the current position, and our goal state is home pose. Home pose. Apologize for how laggy it is, but we are going to now run it with it being collision aware. And we're gonna plan first. So when we plan this, it just did it right there. Now we're executing, and we'll watch it on both of these. So there it is, moving in real time. Moving, the actual robot is on Gazebo, and the simulation, not the true robot, is on Arviz. So, and then that is our pedestal that was built in Gazebo, and on Arviz you can't see the pedestal, but you could probably build it later, but that's the setup right there. And that's how you move a robot in Gazebo using Move It.